Hello and welcome to Module 6. In this module, which will be your last hands-on video tutorial, we're going to use Grasshopper as a real-time simulation space. So far in this course, we've only used Grasshopper to create static geometry. So for instance, we've defined geometry, we've created, and then we transformed it using parameters such as sliders. But the geometry itself does not respond to forces. It does not find its own shape. In this module, that changes. We're going to combine two plugins. One is called Kangaroo for physics-based simulations, and the second one is called Ladybug for environmental simulation. So by the end of the tutorial, you will have built a catenary pavilion on the ASU campus and analyze how the structure impacts sunlight on the surrounding surfaces. So this is where we're headed, a structure shaped by physics and then evaluated environmentally, all inside one Grasshopper definition. Now, let us understand the theory behind this, starting with form finding and Kangaroo. But before we delve into Kangaroo, let us understand the relevance of form finding. Patrick Schumacher, who's the principal of Zaha Hadid Architects and one of the leading voices in parametric design theory, describes it as a physical setup where form organizes itself. It is not drawn by hand or invented or preconceived. It emerges out of a natural process that then we can computationally recreate. The oldest documented method of physical form finding is the reverse hanging model, used for designing arches, vaults, and shells. It is a physical model with an elastic cable or membranes with no rotational stiffness, subjected to gravity forces. And this is to obtain a structural state of pure tension. This form is called funicular, which is then, when inverted, identifies a compression-only version of itself. So Robert Hooke first proposed this in the 1700s, and he proposed a reverse curve generated by hanging a chain under its own weight, supported only at its end. Define the optimal structure form of an arch. This curve is called a catenary curve, and we don't want to confuse it with a parabola. They're geometrically and topologically slightly different. So Antoni Gaudí was one of the first architects to apply this principle at the scale of a building. For the Colonia Güell Chapel and later the Sagrada Familia, Gaudí built elaborate hanging chain models weighted with small bags of sand to simulate the loads of the structure. He then photographed the models, flipped the images upside down, and used the inverted forms to trace over and define the arches and vaults of his buildings. His models were some of the most complex physical form finding expressions ever constructed, with hundreds of weighted strings creating intricate three-dimensional networks. The resulting architecture is structurally pure compression, which is why these buildings could achieve such dramatic forms without the need for flying buttresses or heavy reinforcement. Frei Otto, another architect and engineer, took the same principle further and used it to find the structural form of reinforced concrete and masonry vaults, shells, and steel or timber grid shells. His technique takes advantage of non-rigid nets under gravity, custom loads, and fixed boundary conditions for form finding. The multi-hall in Mannheim is probably the most recognized building designed with this method. Other form-finding experiments, such as stretch membranes under pressure and soap bubble models, led to notable projects like the German Pavilion and Expo 67 and the design for the Stuttgart Station proposal. Today, traditional form-finding techniques are applied digitally using particle spring systems that simulate the physical behavior of deformable forms. Initially developed for character animations and cloud simulation, particle spring systems created in software such as Maya or recently in Rhino Grasshopper or Blender have emerged as powerful techniques for form finding. Whereas traditional methods are difficult to apply, digital simulations allow designers to investigate form in real time by updating forces, supports, and physical properties. From a conceptual standpoint, it also provides freedom to look beyond the limits of physical form finding, which is always directed towards the structural optimum. So Kangaroo is a library and set of Grasshopper components for form finding to conduct physics simulations and geometric constraint solving developed by Daniel Pike. Daniel Piker has been really active part of Grasshopper community since its inception. And in recent versions of Rhino and Grasshopper, Kangaroo is available as a default library and its features are accessible within Grasshopper. So you do not need to install it in any form. So this diagram explains a typical Kangaroo workflow, highlighting three critical steps, which are geometric discretization, goals, and solvers. A particle spring system discretizes a continuous model into a finite number of masses called particles, connected by perfectly elastic springs. So here we can recall, for instance, model created by Gaudi, right? It requires geometric input in the form of points and lines to simulate various constraints. It also works with meshes since their topological structure is defined using vertices and edges, and we can think about meshes as two-dimensional, basically network of lines. So the first step in any Kangaroo workflow involves discretizing the form to relevant points and lines for initial input geometry. And in order for us to do that, we work with mesh geometry types and not NURBS, because meshes allow us to extract the vertices, the edges, etc. So the constraints applying to these points and lines are called goals. A goal can be understood as any function that displaces certain points to a new location based on their new current position. So Kangaroo constrains many different types of goals. You can also think about them as different types of forces, which can be applied in any combination. Kangaroo will compute the goals to meet them and basically come up with an average force applied to any nodes. If the goal conflicts with each other, no simultaneous simulation is possible. The points will find a compromise between them, so think about this as averaging the forces. More specifically, it will minimize the sum of their weighted squared distances from their target. So each goal can be assigned a scalar value for its weight or relevant importance. The Kangaroo solver is the component that collects all the goals or forces and solves the system, right? So the solver automatically runs until the goal converges or the goal settles. All the forces then reach geometric equilibrium and then stop. For simple setups, this can be pretty much instant, which is going to be the case for the definition that we'll look at today. So you will just see it. For larger or more complex sets of goals, it will display the current state every, let's say, 15 to 30 milliseconds approximately. And sometimes you will see basically the geometry being configured, and then it will settle once it reaches its equilibrium. In earlier versions of Kangaroo, this was more visible, but I have to say that as the software is more in its more stable version, you do not really see this calculation, but you can actually extract the information, but usually the simulation is instantaneous. So this is the typical Kangaroo workflow. Let's start off by downloading the base Rhino file that we'll be using to construct this tutorial. Let's go to our canvas. Let's go to Files. And under Module 6, you'll find two files. The first one is a .osm file. That .osm file is similar to a cropped portion of ASU campus. And in this case, I'm selecting this Herberger building, which has a garden, a secret garden. And we're going to use this as our base geometry because I think This will create interesting shadow opportunities, and the height is, I think it'll work well with the catenary pavilion that we want to construct, but just think about this as a generic site. Now, you do not need to necessarily download this OSM file, just know that that's where I'm getting the geometry, but go ahead and download this .3dm file. So select and download. And then let's go ahead and open this file. And I'll talk about different layer structure. Okay, so what you're looking at here is ultimately this building in 3D. I'm only selecting this building as 3D, so I downloaded and modified the 2D and 3D. So let me walk you through the layer. So there's a default layer here, which we're going to keep activated. There's a 2D site, and the 2D site, in this case, I'm locking, so it has 2D ways. So these are the roads and different boundaries, and then it has 2D buildings. So this is for context and scale, so we don't need to really modify them. So let's go ahead and keep them locked. Then there's the legend. This is a point randomly placed here. We're going to use this later on. Let's go ahead and keep that locked as well as turn that off. Then the next element, I'm going to unlock it. It is the 3D building. So that's the boundary we're looking at. So this is going to be used for us to then simulate the shadow that's going to be cast on the ground. If I were to turn this off, then this next layer is the courtyard. So this is the surface that we're going to be using to cast our environmental analysis on. And lastly, we have this boundary. I'm calling it catenary pavilion, and that's going to be the starting point of our pavilion. So we are working in meters because, as you recall, OpenStreetMap GIS is working in meters. And for your reference, I'm going to run the distance command here. If I measure from one end to the other end of this square, it's 15 meter by 15 meters. So it's quite large. And we're keeping it quite large to be able to kind of visualize and first in a diagrammatic way. So think about this as maybe a commission that you might be getting to design a pavilion, a catenary pavilion inside this courtyard of Herberger. So to begin, I am recommending that we keep the building off, and we also keep this ground off, and then let's keep it locked. So I have everything off except for this catenary pavilion boundary. So I'm also going to turn this off, and this will allow us to first just understand how Kangaroo works, set up the pavilion, and then manipulate things as we go forward. Last thing, by default, I have the grid, the origin grid off. If you press F7, you'll see that the grid will be turned on, and the way this file is set up, this pavilion geometry is right at the center here, so then we're able to manipulate and orient things accordingly. Great, so I'm going to turn it off again, F7, and we'll proceed. So let's go ahead and in our command line called Grasshopper. And first we will begin constructing our pavilion using Kangaroo. And Kangaroo is already pre-installed with Rhino 7 and Rhino 8. So I'm going to extend my window a little bit. You'll see that we might have more add-ons as you might have. In our last module, we installed Caribou, we start human. For our previous module, we used Lunchbox. So don't worry about any of these tabs that you might not be seeing. Just understand that these are add-ons that we can extend, we can install or uninstall using our plugin manager. You just want to make sure that you have your Kangaroo 2 tab. And if we open Kangaroo 2, you'll see that there's quite a lot of different menus available. So going back to the video we were looking at, I'm going to talk about goals, and I'm going to talk about solvers, and then the geometry that we need to construct. So as earlier discussed, we're going to be working with meshes. and meshes have vertices, edges, and faces. So you'll find a lot of different mesh components that are available here. And although in Grasshopper we do have our mesh tab here, Kangaroo has certain top number of utilities that we're going to be using, but I want us to also install another plugin that exclusively works with meshes, and that is called Beaverbird. So Beaverbird, you don't have that already. We're going to go ahead and install. So anything we install, we will go to our command line and we will enter plugin manager. And we will go ahead and enter package manager. And once you open package manager, go ahead and type Beaverbird. Beaverbird. And this is a great plugin developed by Giulio Piacentino, and I would say it really, really changes the way that one is able to work with meshes in Rhino Grasshopper. So you'll see the capability. So go ahead and select, and I already have it installed. So I can uninstall or install again, click on install, and once it's completed, you do need to restart. So let's go ahead and save your Rhino file, and then let's open it again. And next time we open, we should have in Grasshopper our Beaverbird plugin. So that's WP and stands for Beaverbird. Okay, so I will talk about Kangaroo 2 and Beaverbird in the next section. And let's begin. So with Kangaroo, we are working with geometry, so in this case, meshes. So when you're working with Kangaroo or meshes, you could use number of different utility tools here. So these tools don't construct mesh, but once you have the mesh, they'll allow you to extract or refine. Same with our Beaverbird. Beaverbird does not allow you to construct other than some primitive options that it gives us, but it allows us to extract and then modify. So in this case, increase the subdivisions or extract different types of operations from there. So in order for us to construct meshes, we would be using our native Grasshopper mesh tab, or we can construct a mesh in Rhino and reference. So before anything else, I'm going to minimize my window momentarily. It looks like it didn't, my preview wasn't saved. So I'm going to go ahead and turn these off. And the only thing that's remaining is basically our catenary pavilion. So I'll recall Grasshopper again. And this is what we're going to be using are these blue boundary, which is called catenary pavilion, as the boundary for us to construct our mesh geometry. So let's go ahead and go to our Grasshopper under mesh. We're going to use a component under primitive, which is called mesh plane. So go ahead and select mesh plane. And you'll see that by default, it creates a boundary. So it has a 20 by 20 boundary. It has a width and height. Now, when you drop this, you might see mesh subdivisions, you might not. Under display, you'll see that there's an option here, Control M, where if you select Control M on or off like a Boolean, you could see the mesh subdivision. I recommend we keep the mesh subdivision on. And so now I'm able to see the division, and it's telling me that this has 10 elements in width direction and 10 elements in height direction. And the boundary is preset, but what I want to do is I actually want to use this blue line as the boundary. So boundary could be received in this case as a rectangle. Rectangle is a type of curve. So let's go to our parameters. Let's go to our geometry. And I am going to grab a curve container. And we're going to right click, tell it to set one curve and select that as a reference. And then connect this to the input of the boundary. And there it is. This is now our new mesh boundary. And I'm going to group this to itself and Control G. And I'm going to say this is my referenced pavilion boundary. Right? So next thing, let's create sliders to adjust the width and height count. I think this 10 by 10 is a good number to work with, but we're going to actually just connect a slider. Create a slider that goes from 1 less than 10 less than 30. But we're going to keep it at 10. And I'm going to actually, for now, keep the same number for width and then for height count. And then I'm going to group this two together, Control G, and say this is my base mesh. Okay, so we have our geometry. And let's go back to Kangaroo right now. And I'm going to now, before introducing goals, and goals are different forces, which we can have in a form of lines, form of meshes, or in a form of points. And we have another component, which we discussed earlier, called solvers. And we can have different types of solvers. Think about solvers as the engine. So these are different ways that we can run the simulation. So there's quite a few different types. And as Kangaroo is evolving, these types are also expanding. But I have to admit that for most things that we want to do, the simple solver is definitely good enough. And this is appropriate for us to start with. So this is under Kangaroo 2, under main, grab a solver component. And this is a component that has the Kangaroo kind of preview by default. And let's see what it's asking for. It's asking for goal objects. It has a reset switch. There's a threshold. There's a tolerance. And then there's the on and off option. So I have to say that for most parts, you don't need to adjust the threshold and tolerance. Reset and on is really critical. So reset, think about this as a switch that you set up the switch on and off. And then on is having your basically simulation continue running. So reset is turning your car engine on. And then the on is continuously, let's say, keep it running, right? Having the fuel to keep it running. So both of these are Boolean toggles. So this one by default is set to false. This one is set to true. So let's first set this up. I'm going to go to parameters under input, grab a Boolean toggle, and I'm going to group this to itself. And I'm going to change the colors for the solver. I'll go more blue color just so you can visually separate them a little bit better. And then I'm going to say this is my reset simulation. And by default, it's false because you don't want to constantly set it up, right? You don't want to constantly turn on your car. You want to keep it running. And then the on, I'm gonna copy this. And I'm going to say, this is basically your, let's say, if true, continue with simulation, right? So you just keep running it. All right, so then I'm going to set this to true, and then I'm not going to reset it, right? So you'll see that at some point we need to come back and reset, but for the most part, you don't need to touch this basically this continuous simulation. Okay. Then it gives you this very critical input on top, which is the goal object. So any forces that we want to apply to our geometry, whether it's a point force, a line force, a surface force, basically a mesh force, everything goes here. So this becomes a crowded input. We'll come back to this. Once you provide forces, and how do we do that? We take the geometry, we introduce different forces like spring forces, gravity forces, wind forces. We provide the goal, and then it does the simulation and then provides output, which could be how many iterations it's running, what are the vertices, because if you recall from the slideshow, everything is being simulated on particles. So basically, we're by default generating points. And then if you do have other types of objects, such as meshes, then you can have the output coming out of here. So we're going to spend some time setting up our goals. So I'm going to just move this away a little bit. And I'm going to sample this color and say that this is my solver. I'm going to say slash, this is my physics engine. All right, so we need to do a number of things here, depending on what we're trying to create. So I have a mesh here, and I want to do the catenary simulation, which means I want this to behave as an inverted catenary curve. And I can decide whether it's the force is pushing up or pushing down. So I want every single one of these edges be converted to springs. And I want to apply gravity to the entire surface. So what we need to do first, let's go ahead and find our forces. And this is where some of the names might be tricky initially. They don't kind of translate one-on-one for all the forces. So if I go to kangaroo, you'll see that there's some forces, such as if I go here, like an angle force, so it forces your geometry to fold. Or if I look at, for instance, different collision or different, let's say, rigid body force, some of them are more straightforward, but this is everything to do with working with lines. So in this case, for instance, if I want to convert a line to a spring, I will be working with one component here. So in earlier versions of Kangaroo, the terminology was more explicit. So for instance, this component was called spring forces. But right now, this is just called line. So let's grab this. So under Kangaroo 2, goals line, length line. And if I look at this, it tells me that at the end, you provide a line, you adjust the strength, adjust the length, adjust the strength, and then it becomes a spring force. So line is basically a line segment. So I need to be able to extract every single one of these. Length is property of the spring. So for instance, when you have a spring in your hand and you, let's say, try to expand it, when you let it go, it's trying to go back to its original length, right? So that's the length. If the original length equals, if your final length after going back to its original, it's equivalent to the original one, then your spring doesn't change its property, right? But sometimes if you play with it too much, if you introduce heat, the length might change. So this is one of the ways where we can change the property of our geometry. Then the strength, this is, I think about this as the strength of the material. So how fast or strong it's trying to preserve its shape. Okay, so it looks like here I need to find my lines. And we're going to do that by, and we can do this in a couple of different ways, which is extracting these lines. So if we just go to our native mesh tools under analysis, there's ways that we can extract mesh edges. And this works, but the problem is like it's separating between naked edges. So the naked edges are edges of the geometry that are open. So when you are 3D printing, you're checking to not have any naked edges. So because you want your geometry to be completely waterproof, right? Versus interior edges are these. So in this case, if I'm using this, I need to use both of these buckets, but I want to show you a better component. So I'm going to delete this. We're going to go to our Weaverbird tab that we just installed, and under extract, it has these tools for extracting, in this case, for instance, mesh edges or mesh vertices, right? So that's what we're going to use. Under Weaverbird, we're going to use Weaverbird's mesh edges. And we can provide a mesh. So in this case, that's the mesh output here. And then it returns lines. So if I look at the output by grabbing a panel, so these are different lines. And it also gives me the length. So the next step for us is to take these lines and feed it as the line input. And what it will give me after this is springs. So it takes the lines and it converts them into springs, right? So I'm just keeping this for ourselves. We're going to eventually delete these. Just know that it takes geometry and then it turns them into springs. And then we need to provide the output to the input of the goal. So now that's already a spring force. And if you look at it, you'll see that it actually extracted these points. So take a look at it before and after. So this is my geometry. And after I basically create my mesh, it is starting to kind of visualize the particles here, right? So I'm going to grab these two together, Control G. I'm also going to change the color a little bit. So I'm going to make all our forces maybe something like this color. And I'm going to make that the default color. And I'm going to call this our spring force. Great. And then the length, if we don't provide anything here, by default, this is going to try to keep the length as minimum as possible and preserve the original length, which would be in this case 1.5. But let's try to play with this variable. Let's grab a default slider under parameters input number slider, and let's keep it 1 for now. And let's connect that to length. And as soon as we did that, as you could see, it looks like our geometry just crumbled, right? So because I played with this length, it is actually shrinking. And if I change the number again, you'll see that, yes, it is actually shrinking. So it took this original mesh and I am converting into springs, and then by changing the length, it looks like the mesh is shrinking, right? So it's a little bit difficult to tell what is folding into what. But if I also disconnect this, you'll see that now it's actually falling apart, but it's still flat and it's not connected or anchored anywhere, right? So if I want to reset this, if I don't want to see this, all we have to do is to just press this reset option. And then I make sure that this is set to false. And then I can connect again and you'll see that it's happening again. So for us to proceed, my recommendation is just set this back to true and then set this back to false one more time, and then we could proceed. Okay, so it kind of works, but it looks like it's always going to be an issue here because if we don't have things anchored, then this thing is always going to shrink towards the middle, right? So anchoring is a type of force that we could apply to our geometry. So under goals point, we're going to have a number of different ways where we can anchor our geometry. So under goals point, we have anchor, we have anchor XYZ. and then we have a plastic anchor, etc. So we're going to just use a regular anchor, and this anchor is going to allow me to, let's say, I'm going to anchor the corners. So imagine if this is my structure, right? It's not going to just shrink and disappear in the middle. I'm going to keep it in place. So let's go ahead and go to goals point and grab an anchor component. And let's see what it's looking for. What it's looking for is point or points to anchor. It's asking for whether we want to introduce maybe a more favorable place for us to pull towards, and then strength. By default, this is set out to be 10,000. So this is a value we can adjust later. So first thing is just extracting the points. So to extract points, just keep in mind that if I set this back, this is my original shape, right? And I want it to be kind of preserve the original boundary, meaning I want to use, for instance, these corners for anchoring. Later on, we can change what it's anchoring to. So meaning I need to be able to extract those points somehow. So first of all, these points, it looks like I actually don't have these points on this side. I'm only visualizing it after it's creating the simulation. So we're going to do this by actually extracting the points before the kangaroo. And in order for us to do that and not kind of mix these up, I recommend select your kangaroo solver, right click, and turn off the preview, and you'll see that, yes, those points are set up here. Then we're going to go back to our Beaverbird, and then under Beaverbird, under extract, we're actually going to use another component called Beaverbird's vertices component. So we extracted the edges. Now we're going to extract the vertices. And similar to what we had, we're going to provide the mesh input, and this component is going to extract the points, right? So now these are points that I can work with before I simulate things, such as I can anchor them down. So although it's taking a while for us to set this up, but once you have this definition ready, you can just replace this mesh with any mesh, and you don't need to change everything else after that. So this is a really good generic definition we're making. So I have the points, but I want to extract them. So in earlier tutorials, we looked at how we can, by knowing index of a point, we can, for instance, extract them. So I want to visualize the order of the points. So we're going to go to our display tab under vector subtab. We're going to grab a point list component, and I'm going to provide the output of the points to input of the point. And this is for me to learn the index number. So let's go ahead and grab a generic slider, and that will tell me the index number, right? So for instance, I could extract number 0, and I can extract number 10, and I could extract number 120, and then 110. So by knowing the index, we can extract them, and we can use them as our anchors. So that works if, let's say this condition never changes, but let's say if I change my mind and if I change number of, let's say, divisions, you'll see that those numbers will change, which is going to make it difficult if I always want to, let's say, anchor the corners, right? So I'm going to slide this back to 10. I wanted to just prove a point. So one thing I want to introduce you to is under Kangaroo 2, it has a number of tools under mesh, which allows us to say, well, I don't care how many points you have, extract, give me the corner, mesh corners. And we can use that to always, regardless of the size or how many divisions we have, anchor the corners. So here under Kangaroo 2, mesh, grab the mesh corners component. And don't worry about this. We're going to use this for something else. For now, let's go ahead and connect output of the mesh. And I'm going to just slightly reorganize this. Output of the mesh to input of the mesh. And you'll see that what it'll do is it will anchor these corner points. And I'm going to just make these a little bit smaller. So you'll see that now it's extracting these corner points, which means I can then provide these corner points as points to anchor. And we're not going to, for now, change the property of this. And I'm going to just group these together, Control G, and say these are my anchor points. And let's see what happens if I connect my anchor points to the goal object. So I have my springs, and then I want to anchor the corner. So if I connect it as is, we know that Grasshopper by default only takes one wire. So just make sure that you have your one of the wires connected like spring, and then hold your shift and then connect the second wire. So now I'm going to go back and turn on the preview of the solver. And I'm going to set this to false. I don't want to reset it. And you'll see that now it is actually pushing inwards, but the corner is their anchor. So to show you this better, I'm going to go ahead and turn off the preview here. I would also select these and turn off the preview. And I would also select this and turn off the preview. And you'll see that it is basically now taking the same mesh, but I'm able to anchor the corners, right? And this is now returning the simulation here. And if I play with this variable, which is the length, you'll see that it's now shrinking more or shrinking less, but it doesn't matter, right? Because it's anchoring the corners. So I think this is really exciting. This is our first physics simulation that we're doing, and it is actually working. So there's this other variable such as strand. So right now strand is set up to 10. Let's grab another slider, and then actually let's delete these two. And I'm going to grab another slider. Let's go from 0 less than 10 less than 100. And if I connect it to strand, and if I start to increase it, you'll see that the points are starting to move, right? So you see that it is actually readjusting a little bit, but actually the majority thing that it is impacting this is the length. So if I remove the length, so hold Control to remove, you see that by default, it goes to what it was. And if I even reset this, it is still trying to keep the original shape, right? Because there's nothing pulling it in. There's no, it's not pulling it up or down, right? But by shrinking it, we're basically shrinking the fabric. Okay, so far so good. This works. But the next force that I want to introduce to this is gravity. And gravity is what's going to allow us to take this and turn this into a catenary structure. So let's make sure that I connect or add these slider to the group. This is my spring force. These are my anchors. And next thing we're going to look at is the gravity force. So gravity force in earlier version of Kangaroo was called unary force, so uniform force. And right now under goals point, that ultimately acts as the gravity force, which is called load. And this is a force that we can apply to any point. And this could be any vector direction that we provide. In our case, gravity, if it's negative z, right, it will push down. If it's positive z, it would push up. So this is the force we're going to be using. So grab a load, and going to create a little bit of space here. And let's see what it's asking for. It's asking for points. These are the points that I want to apply force to, right? So we already have these extracted from our Weaverbird. So if I turn these on, if you recall, these are the original points, right, before they shrink. So I'm going to keep it on. And actually momentarily, I'm going to turn this off. I'm going to reset this back to true. And we're going to provide the points as the point input for our load force or unary force or gravity force. And by default, this has a vector of positive z direction. So actually it's going to push up. If I want this to be negative, I need to either provide a negative vector or a negative value. So I can do that by changing the slider value here. So right now by default, this is set to 1. Let's set up a slider that goes from -10, less than 1, less than 10.0. So -10, less than 1, less than 10.0. And we're still going to keep this on 1. And that's the weight. And I'm going to, for now, just organize this a little bit. This is my points. And then this is my gravity force. And I'm going to group these together, Control G. And we're going to call this our gravity force. All right, so next thing is we want to connect this gravity force or unary force to another goal object. Now, in my case, the reset is set to true, and also on is set to true. So for me to add another wire here, you want to make sure that you hold down Shift and connect it using Shift, otherwise it would replace the wire, right? So then go ahead and double click on reset. And once it becomes false, you'll see that now it's actually pushing up and your surface is being kind of moved. So it's the same basically fabric that's shrinking in, but it's also being pushed up. And if I start to increase this number, you'll see that, yes, your catenary arch is being constructed. And then if I go in the negative direction, it is a hanging chain model, right? So you can see that very easily we were able to replicate that Gaudi catenary arches, right? Okay, so a couple of things at this point. We want to first get our preview working a little bit better. So now that you understand how points work, so these are basically our preset. And anytime that if you feel like a preview is not helping you, just select and turn it off. This one actually doesn't give you any preview, it just helps you push things up and down. And all the preview right now is being generated after it's being simulated. So here. All right, couple of things. If you are changing something that's scaling the force, so in this case, I'm changing the z direction or I'm changing the length, my simulation is running. However, if you change something that's fundamentally changing your geometry, for instance, in terms of number of points, so if I increase this, you'll see that it is just doing random things. Because while this is running, I am telling it to add subdivision. So once you do that, you just need to reset, right? So when you change something like a subdivision, just reset and then run again. Now it's going to work, right? Right now I have more control points. So anytime you start to see that maybe your solver is turning red or your simulation looks funny, like now, like that, you just need to reset it, because imagine your engine, your car is running while you're trying to, let's say, add something, right? So just reset it. There you go. So now it should be fine. For the sake of this, let's go back to 10 by 10. Again, I need to reset. Okay. Then let's try to also look at other things. If you recall, for instance, our original geometry that we had was a mesh. So we took from the mesh the edges, the points, and we're simulating it so it works. It's exciting, but it is not returning a mesh. So how do I take that and turn it into a mesh, right? So how do I recover the faces? So by default, it is simulating particles and lines. However, there's an option here under main called show. So think about this as kind of a hide and show like we have in Rhino. So if you grab this component called show, you need to tell it what geometry you want to recover from the preview. So in this case, what I want to recover is this mesh. So all you need to do is you need to tell it that, hey, I want to visualize a mesh. So provide the mesh. And then we also add this as another goal object. So bring it near here. I'm going to group it to itself and say, here is preview mesh. And let's connect this. So hold down your shift and then connect it here. Now there it is. You are also looking at a mesh, right? So at this point, I can go back and turn this off. And there you have it. All right. Let's go ahead and save what we have so far. So just in case you don't lose it. So we're using the same naming convention. So the file that I've given you, first name, last name, tutorial, just make sure that you replaced this with your name. So I'm going to go ahead and save this as well. I'm going to use this, my first name, last name, and I'm going to save this as 6.1. I'm going to save it to desktop, and I'm also going to rename this. So when you upload it, we do have this with your correct information. Next, we will look at how to manipulate this surface further. So by default, we're using this component that extracts the corners. But let's say, what if I want to anchor more points? Or what if I want to, let's say, subtract some of these openings, right? Because right now this is kind of a perfect form. So we're going to look at a few different ways that we can manipulate this. So for that, I'm going to swap this gravity with anchor points, and we're going to continue working here. So if you recall, we have this component called point list, which it provides the order of the points, right? So from the original setup. So I'm going to go ahead and turn our reset back to true, because I want to basically turn off the simulation. And we're going to spend some time deciding what it is that we want to anchor. Let's say I want to anchor this number 36. Right now, this is a random number I'm picking. I recommend we use the same initially, just to look at the same thing. So let's say I want to anchor that number 36, right? Or I want to anchor 96, or I wanted to also maybe have a larger footing here, right? Because right now everything comes down to those corner points. So to extract these points, we will be going to sets list. We're going to use an component called list item, which we've used before. And that will become maybe additional points that we can provide to this component to add as anchors. So I need to provide these as numbers. So let's go ahead and create a panel, quotation mark. And let's enter the numbers that I want to provide, like let's say 36. And then go to the next line and let's pick, let's say 85, right? So across from one another. So we want to do 36 and 86. When you have more than one entry in a panel, you want to right click and click on multi-line data. So they get their own index, and then provide that as the index input. So I have these index input, but what is it that I want to extract? So my list is list of points, right? So these are the points that I'm extracting using the VRBR plugin. So I provide the points as the list. Then these are the numbers that I'm going to extract. So you can see that now when I select this, these are the numbers that I'm extracting. So if I change these numbers, those would be also extracted. And then all I need to do is to just provide these as anchor points. So since I am providing maybe multiple points here, I need to be careful that either I need to hold down shift and connect them together, Or I can use a component such as merge, double click and type merge. And that becomes a great way for you to combine. Let's say I want to merge these anchor points and these corners, and ultimately gives you a new list of points. Got this? It gives me those points and then these 4. So it should right now give me these 6 points. I don't need to look at these. This is for you to see. And I'm going to, instead of connecting this here, I'll take the result of the merge, right? So now these are my anchors. Then let's try to quickly organize this before we run the simulation. So just take these components and add them to your anchor. And we'll come back and deal with the preview later. Let's just run the simulation. So set this to be true, and you can see there it is. So these are your anchor points. That's right now pinching and basically keeping in place, right? So let's slightly adjust the preview. I'll make these points smaller so you could see. And then I can go back and also, for instance, adjust this. I can adjust the strength. So let's make it more powerful, less powerful. I can change the weight, right? So now it's starting to look more like a pavilion with multiple footings. Now, keep in mind that basically, in order for us to have high resolution, we would need to reset that. Okay, so these are working. So let's say, I think this works, but let's say if this is a large, because this is 15 meter by 15 meter, I think these are going to be weak points. So my recommendation is to actually create anchor points that are more along the edges. So for instance, right now this is 0, which is a corner. I'm also going to provide 1 and 11. I'm also going to provide 9 and 21, and etc., etc. So let's try to do this one by one. And then we're not going to have any anchor point in the middle. We're actually going to subtract 1. So just follow this along. I'm going to go back to my indices, and we can just all use the same number. I just need to be aware that it will require resetting. So you can see that when it's red, it requires resetting. So it's red because right now it's empty, so don't worry about it. We can fix this. So the numbers that I want to extract is, I want to have, let's say, 3 points, but I'm already extracting the corner. So go ahead and enter 1, next line, 11. Next line, let's do 9 and 21. So enter 9, next one, 21. And you'll see that it's going to start to connect this. Oops, it didn't take 1 and 11. So I'll do 1, 11, 9, 21. Then we're going to do 99 and 100, oops, 111. And you'll see that now I'm starting to anchor these corners. And then I also want this one, 109 and 119. So I'll just also add 109, then 119. I'm going to put this up. So if we are using a 10 by 10, these numbers should work. And you can see that now your pavilion is anchored better. So I'll just leave this up. So I'm just literally finding these numbers. So because the corners are already anchored, right? Because we have this corner condition already, but I'm just taking 1 and 11, this one and this one, that one and that one, and that one and that one. So you can just copy this number, 1, 11, 9, 21, 99, 111, 109, and 119. Now the order of these doesn't matter. Whatever is going to be easier for you to modify, right? Now, keep in mind, if we change the division, this is going to change, but I think this is a good resolution for us to proceed, right? So now this, I think, structurally is better. And I'm going to then proceed to the next step, which is, what if we start to subtract? So these are different ways that we can work with meshes. Now, For this specific instance, I want to show you these operations. Of course, for your design, you can decide whether subtraction is something you want to incorporate or not. But along with this, I want to show you more of the mesh operations. So basically what I want to do is before I provide the mesh to turn into forces and anchor points, we're going to modify the mesh. And we're going to do that by going back in our Grasshopper native tools under our mesh tab. We're going to go to our utilities, and you'll see that under utilities, there's a number of components that allow you to remove faces, right? So with meshes, we have vertices, edges, and faces. So we're going to look for this component called delete faces. So select delete faces. And it's telling us that give me the mesh and then tell me which index you want to delete. All right, so let's see how we can extract that. So in indices, these are so far what we have. These are our points. So these are our vertices indices. But what I need to know is, and I'm going to, I apologize for the wires being kind of messy right now. I'm going to reset this back to true so we could just understand the mesh. And then we'll come back to this part and reorganize it a little bit more. For now, I'm going to leave some room up here. So what I want to know is what is the index, what is the order of these faces, right? Just like points along the edges, right? The vertices have an order, just like edges have an order. Faces also have an order. So to do that, I am going to use exactly this component that we use, which is point list, right? So we can either copy this or we can grab another one by going to our display tab, vector point list. But I need to find the point that I want to visualize. So we're going to now find the middle point of these faces. So let's do that by going to our mesh tab. Under analysis, we're going to look for a component called face normals. Face normals. And what this component does, we can provide the mesh. It takes the mesh and it provides a normal vector as well as the center point. Now I can use that center point as the point input. And I'm going to grab another slider, just the default slider, increase the size. Now I have the indices of the faces, right? So those were indices of the vertices. These are indices of the faces. So to make it less confusing, I'm going to turn off this point list and just keep the one that's showing the faces. All right, so this is a design decision we want to make. We need to just decide, maybe eliminate one or two of these faces. So these could be like openings that we have for our mesh, and we can decide whether we want to anchor them or not. So let's say I want to remove number 44, and I need to provide the mesh, and whichever one I like, so this is the mesh, I need to provide the index that I want to remove. So just like here, we're providing index to remove or isolate. Here we're providing an index to delete, right? So let's use another panel. And then I can just select whatever that number is, let's say 44 randomly, and provide that to the indices. And you'll see that it's reconstructing the mesh. Now it's deleting that one, right? So if I want to delete multiple, let's say let's delete that one and 57. I just need to make sure that after more than one element, I need to right click and tell it that it's multi-line data. There it is. And now I'm deleting two different, let's say points, right? So let's look at this as a design decision. Maybe I want to balance this a little bit better. Maybe let's delete number 37 and 63. Let's do 37 and 63. So I just want to show you that these are just decisions you can make to make, let's say, your geometry modified. Now, instead of this mesh that I'm originally using, this is now a new mesh where if I were to, I'm going to just momentarily turn off the preview here for you to see. Now, this is a new mesh. So if I want to just simulate this, actually all of these connection to meshes need to be replaced with this new mesh. So to make this a little bit easier on us, I'm going to say, this is just for me to visualize. I'm going to group this together and say, actually, let's do this. I'm going to make this the same color. I'm going to group this together and I'm going to say remove mesh bases. And basically original mesh, then I remove it. So what does that give me? It gives me a new mesh, and then I can use that new mesh to simulate. So to make this a little bit easier, we're going to go to parameters, geometry, and grab a mesh container. And I'm going to basically say, I don't want it to connect here or connect here. It's always going to connect to that point. So one thing I want to show you, and this is a really good trick. Here, as you could see, I have 4 different wires, right? And then I have 2 more that are going here. So deciding how you want to reconnect things sometimes could be tricky. So we can do this in 2 different ways, and you decide which one is better. I'm going to repeat this twice and just see which one you like better, and then I'll pause so your wires are connecting correctly. So one option could be I could just take the new mesh, and then I could use that to just reconnect here, 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 and here, right? So instead of there, that goes here, and then I'm connecting here. Now, to double check, if I were to run this, and I turn on the preview, I should see that, right? So you can see that now that's anchored, right? Why is it anchored? I didn't enter these. Well, here we have a component that tells me that anchor the edges, right? So those are the edges. So this is a great way for us to just actually stylize our pavilion. So I'm going to go back and just for a moment, just focus on the wire connection. Alternatively, I'm going to Control Z for you to see. When you have a condition like this, let's say if we had less wires, so in this case, there's only 2 going here. I'm going to delete these 2. I'll reconnect it later. I want to show you a nice trick. When you have a condition like this where you have a bunch of wires going into one input or output, and you want to just replace it with something else, you can hold Control Shift, and then just move a bunch of wires together. So now I'm able to do again, Control Shift, move a bunch of wires together, and then now that basically becomes my mesh. That first it goes there, then from there it goes there, right? So no matter how we do it, I will leave this up for a minute just so you check your wire connection. So you have your original mesh. All we did was we just removed some of the faces, and then I have the new mesh. Maybe actually let's organize it this way. I apologize for this. And then I'm going to actually, yes, actually let's add this to this group. That, and then I will leave this up so you're making sure that everything is connected. So you have one of the mesh output that goes into preview or show, then you go into spring, and then you go into your anchor point. So you should have 4 wires coming out of this. And then nothing changes here, right? Everything stays the same. So I'll leave this up. So you can pause, check your wires, and then we will proceed. Okay, so next up, let's look at the output of our solver component. So I'm going to spend some time unpacking this. So right now the preview is off. If we turn it on, we know that this way we can basically look at the simulation. So I'm going to turn off all the preview except for this. So you can just window over everything and then use your middle mouse button and then turn off the preview or do this one by one. So I'm only looking at what is being visualized here. But let's say if I don't want to show the points, how might I isolate, let's say, the mesh preview versus the edge preview? So I'm going to grab a panel, and the first output is basically number of iteration that's been run. So see if I turn this on, so it's basically increasing and it stops, right? So if you have a heavier simulation, this number would go up and down until it settles. Then the next one is, this is all the particles. So this is a list of points. These are basically these points, and the order of these points should be exactly the same order as these. And that it's just they've changed position in space, right? So I'm going to turn this off. The last one is giving you combination of edges, right? So these are the edges, as well as if I scroll all the way down here, it should give us a mesh as a singular object, and then it gives us an empty branch. So I would say this is one of the weaknesses of the current Kangaroo version. In one of the previous versions, it had a better way of separating geometry. Right now, it just gives you everything as a branch. And what do I mean by that? If I grab a param viewer here, it tells me that I have two branches and then with different number of items. So let's just understand where these numbers are coming from. This is 2 to 1, 1 for 1. If I look at the points, that's 1 to 1. So basically, this is a very messy way of organizing information. And then the second branch, which is auto-generating it, it just gives you this empty null objects. So this is one of those cases where I need to basically work with the output, but then clean it up so we can just, for instance, isolate our mesh versus our points. So one way we could do this is if we go to parameters and we go under geometry. In this case, let's say I want to isolate the mesh. If I grab a mesh container, and if I run all of the output through this, and if I look at the output here, you'll see that it actually, it's giving me red because, first of all, it doesn't recognize all the geometry. So it's giving me null because it says that's not a mesh, that's not a mesh, that's not a mesh. The only thing that it's recognizing as a mesh is that. So it becomes a way for me to isolate this, right? So also, if I look at the output of my wires, the reason why I'm seeing this two different branches is because I'm providing forces here that are coming from slightly different data structure. So in the latest version of Kangaroo, it's not really critical to do this, but in older versions, you definitely had to flatten all the forces. I still recommend that we right-click on the goal and flatten. So when we flatten, we get rid of all the extra branches. And I like that because what it will do is, so I'm right-clicking on the goal objects and we're going to flatten. You'll see that it actually gets rid of that dashed line. So now I still have a list with bunch of null, but then there's only one branch, right? So it makes it a little bit easier. Then it's giving me all this null objects, and in Grasshopper we have a component for separating or removing all the null. Just like here we remove a face, we can also remove a data type, which is in this case null. So let's go to our sets. Under list, we're going to look for a component called null item. And this component, basically, it helps us to flag whether an item is null or not. So we're going to provide the output to the item input, and the outcome is going to be true or false. So basically, all of them are null except for that one instance, which is a mesh, and that's where we have that single false, right? So if I know that a question's answer is either true or false, we could dispatch based on that, which is a component we've used before. So under sets, list, dispatch. And what is it that I want to separate? I want to separate all of the items that have null and mesh mixed up. Then what is the pattern that I want to use? It's this null flag. Therefore, all the ones that are true, those are null. All the ones that aren't, that's a single mesh. So this operation, which I would say it's not very intuitive, but what's nice is if we're basically creating a function that you can just continue running different geometry, it would only return the meshes. So I'm going to group this together, and I'm going to say we're going to say only return meshes. So that could be single or plural, right? So the outcome of this is a mesh. Just to make this more explicit, I'm going to grab another mesh container. So again, parameters, geometry, mesh. And I'm going to place this here and then add this to the group. And then this way, I know from this point on, in Kangaroo, I could use this to separate the mesh. So meaning I could hide all of this. And there you go. So you have a clean mesh as the output, right? I'm going to also delete this branch, and we're going to proceed from here. Okay, so what we're going to continue doing in the next segment is we're going to look at our Weaverbird components, and we're going to look at ways where we can take our geometry and we could topologically and functionally enhance it further. So Weaverbird, earlier we used these two components to extract geometry. I can also use it to topologize or re-subdivide my mesh surfaces. And all of these names, so for instance, Catmull Clark, these are two scientists that had a seminal paper, and along with that, they were able to create new subdivision algorithm. So each of these, if you look at the history, it's a really interesting way of thinking about topology. Now, let's start with, let's say, this first one, Weaverbird loop subdivision. Let's grab one, and then I'm going to put this here. So let's see what happens if I take my mesh as is, which is basically inheriting number of subdivisions from here. So what happens if I take this and then provide it as a mesh input, you'll see that immediately it is subdividing this further, right? And is keeping certain things and getting rid of certain things. I'm going to turn off the original one, so then we see what we're looking at. So you can see that definitely it is smoothing it. So now it's looking like a nice shell structure. And let's see what the other properties are. So for instance, it has this thing called a level. So this is subdivision level. And you can go all the way up to 3. Let's make a slider that goes 1 less than 3. And by default, this is set to level 1. And by the time you get to level 2 and 3, you could see that it is just subdividing this beautifully. And what's really wonderful about this Weaverbird components is that it's a very, very light and optimized operation, right? So it just runs super, super smoothly. So if I were to compare this, the original to this, you could see that now this is drastically a smoother surface to look at. Then there's other features as well. So for instance, here, it took basically those corners, and right now it's completely rounding this. Now, if I like this effect, I can definitely keep it. But if I do want to keep the anchors as is, I can change these variables here. So 0 is fixed, 1 is smooth, 2 is only connect the corners. So let's make a slider that goes 0 less than 2. And if I connect this with 0, you can see that it is actually keeping the corners, which actually I think that works really well. Then 1, and then 2, right? So it kind of depends on what it is. I'm actually going to keep this at 0. So then this way I can keep those more anchored, but you can see that it's very, very easily it's changing these properties. So each of these, it just allows you to do further subdivisions. And also under transform, this is where you could even do other operations where if you were to just do it manually, it will take a while and it might not need some cleanup. So for instance, let's say for your studio project, you want to 3D print this. And in order for you to 3D print, you need to provide files that are saved as STL. STL files, stereolithography files, are mesh files. So let's say you want to print this, and then they let you know that you need to have thickness, right? You need to be able to print it with thickness. So here, there's a component called transform mesh thicken, which it's a very, very optimized algorithm for taking any mesh. Now, this value is very, very large, that's 5 meters. Let's make a slider. I'm going to use a default slider. And you'll see that if you just provide a little bit of thickness, and then if I were to just bake this, right? I'm baking this, and I'm going to place that on catenary pavilion. I'm going to close this just so you could see it. Now the edges, I think it needs more work. We can smoothen it further, but it's a perfect thickened mesh that you don't need to do anything because it's watertight, right? It has thickness. So you could just use this component and create thickness and then export this to be 3D printed. So I think this is a really, really good feature. So whether you're using it for this project or other project, use this. I'm going to select and delete it. We're going to go back to Grasshopper. So I think these are really great tools. And if I go back to Weaverbird, there's other features as well, such as how to create openings or perforation as part of the mesh. So let's use this component called Weaverbird's picture frame. So if we think about each face, and I'm going to just temporarily turn this off. If I look at each face as a polygon, this component allows you to create openings. So to see this as a better pattern, let's actually reduce this down to 1. So your subdivisions are a little bit bigger. And then I'm going to connect the output of the mesh, the subdivided mesh, to input. And you'll see that immediately it actually creates this thickened wireframe. And let's make a slider that right now the distance is set to 5. Actually, I am going to just make a copy of this and see if we need to change this number. So yeah, it looks like I need to go much higher. I'm going to right click and set the maximum to, let's say, 20. And you can see that you're basically just creating this really, really optimized lattice with everything cleaned up. So if I turn this off, just look at this preview. Now you have a beautiful pavilion style mesh. And you already have so many variables, right? I can just increase this and just see how clean and quick this is, right? You could take any surface and turn this into a structural component. I'm going to go back to 1. And then if you do want also the window of this, basically, if let's say this is your structure, right? You can go back to here to transform and then grab the opposite, basically the negative of this. So Weaverbird's mesh window, it gives you the opening in return. So I'm going to provide the same thing. I'm going to provide the same value. And then I could, let's say in this case, I will grab a display preview, custom preview. Let's give these different colors. I'm going to go to here, input, color swatch. And I'm going to give it maybe like a light tint with some transparency. And then I will make a copy of this. And then for the frame, I'm going to make it all maybe darker kind of metal color, and then no transparency, right? So if I were to turn these off, just keep the preview, it is like you have basically a transparent membrane that's part of that. And again, it's super, super light. You could just adjust this and everything just adjust accordingly. Or if you want it to be rounded, right? This could easily be a shell structure that you're utilizing. And we can take it a little bit further. Let's say for the thickness of the wireframe, I could incorporate this. So let's say you want to keep a thinner, maybe color frame. Let's maybe give it a little bit of a warm color here. And then for the frame, I want to give it a little bit of thickness. I'm just going to combine that with this. So we'll see that very quickly you're starting to add so much detail to your geometry, but then it is starting to look really interesting. So then I'm going to turn off this output. We would probably need to adjust the thickness. And then we would take the output of the mesh picture frame, provided as mesh input. So now that frame is thickened, and then that's what I'm going to provide for the visualization. So now you have a very simple, structure that again you could bake and 3D print, and it will be ready to be incorporated with the rendering, right? Very simple. And we have so many variables here. We can change where you're anchoring, what you're subtracting, even the overall dimensions and overall subdivisions. And our simulation is still running. At any point, if you get an error, just reset it. And there we have it. So I'm going to organize this a little bit more, and then we'll add more patterning, but I highly recommend exploring this Weaverbird tools. You can get really beautiful patterns and just keep stringing kind of these subdivisions together. So I'm going to group this, then this component, and place them together. Actually, let's add this. I'll keep this separate. Now, let's say at any point you like this structure, but maybe we want to even relax this a little bit more. So what if we want to round these? So I can add, maybe instead of using this and feeding that, what if I go directly, I use something like this to smoothen. So I'll grab another one of these components, and I'll take the output of the mesh. So you'll see that it would actually start to subdivide that further. So then I'll provide that as the input of the thicken. So right now, as you could tell, I'm just playing with these variables, but we went from more of a rigid lattice to something that, and look at it from top view, you're starting to get a little bit more variations. And of course, we can play with all of this. And then perhaps I could maybe even change this initial. So right now we go from this shape to creating the window to this. What if I change the starting shape? So if I go back to subdivision, you have some that are maybe a little bit more, you're introducing shapes that are, maybe it'll give you more variation. So it depends on your design. I mean, the possibilities are endless on how you can combine them. So let's use this one. And you'll see that it always has the same input and output. So I am just going to migrate the wire. So I can go directly from here, or that shortcut that we learned earlier. If you hold Control Shift, you can move the wire. And then I can just use the same inputs here. And then again, Control Shift, just move the wire from there to there. And I can just delete this. So that's one way you can swap things. And you'll see that definitely you're starting to have more kind of subdivision form. I can turn this off. And now if you don't like the style, you want it to be more kind of orthographic, you can certainly do that. But all I'm doing is just combining the subdivision logic, and I think you can get some really beautiful effects that they could be, you know, cut out of sheet material, or they could be 3D printed using composites. So let's organize this a little bit. So first I'm taking the mesh, I'm subdividing it. And of course here I can also do multiple levels. So you can see it's becoming quite lace-like. And I just want you to kind of acknowledge how well it's performing, right? So like we could not do this with NURBS surfaces. We can only do this with meshes. And I think if in your renderings, you can have some really beautiful lighting effects that are coming through. So I'm gonna keep this on level 2. So we have some more openings. And then I'm gonna, so this would be our level 1. I'm gonna just group these, Control G. Then after this, I'm creating the picture frame, and I'm also creating the window. Now I can keep this, you know, I could even have, if I turn this off, so you'll just have openings, right? So it kind of depends on whether you want this to remain open or you want this to have this window. So I think I'll leave it up to you. For now, I'm going to keep mine. And then we're relaxing it more. You can, of course, also run this through this. I think for now we can just leave it as is. And then at the end, we're just thickening this. And for this as well, I can connect it to a level and then connect it to pinning the corner. I don't believe it's going to make that much difference in the texture, but let's see. So I'm gonna keep the corners connected. And then I can also do, you know, further levels here. So you can see that now it's becoming smoother. And then Control M was the subdivision, if you want to see it with or without. And then last step, we're just adding thickness. That's if you want to 3D print. Now with complex shapes like this, if you're providing too much thickness, it might start to overlap. So I think this is where we need to be kind of careful, depending on the outcome. Maybe it would be better to keep this a little bit thinner. So if I were to increase the size, definitely you'll have less chance of these kind of interrupting, but we're not really going for anything specific. I'm trying to just demonstrate this. We can also run one more of this, and here I can have the output here so that your basically openings could also be smoother. I think I'm going to leave this out. I just want to show you that it's possible. And then last thing, I'm going to turn off the preview here. And then let's just select the color that you like here. Maybe you can go a little bit lighter. And then I will just group each of these to the corresponding slider. So this way you can stack them. Then last thing, we're going to visualize this. OG. And there it is. So I'm going to leave this up for now. Now, if you don't like certain effects, you can definitely leave one or two of these steps out. This is not something that I'm going to, you know, grade based on exact visualization. I want you to just take some time and just adjust the variables, maybe try maybe this option versus that option, or you can just leave it as is. But I think it's again very powerful. So hopefully you can use this in your studio projects at some point. And then last thing, I want to just leave this up for you for a minute. And then I'm going to just group, organize a little bit better and then group these so you could make sure that you have everything. And then I'm going to window over everything after, especially this section that I'm doing the meshing. Control G, and I'm going to change the color of the background a little bit. And then these are my meshing tests using Beaverbird. And that would change the way that also light is traveling through so that later on you can come back and do more adjustments. And then I'm going to group this again one more time. And I'm going to say this is my, give it a little bit of blue. This is my mesh post-processing. Okay, now that we have our pavilion, let us talk about how to evaluate it environmentally. So environmental simulation in architecture used to require exporting your model to external software, running the analysis separately, and then bringing the results back. Tools like Ecotech, Radiance, and Energy Plus were powerful but disconnected from the design process. The feedback loop was slow. So Ladybug tools changed that. Developed by Mostafa Salaripur Rutsari, Ladybug is an open source environmental analysis plugin that runs directly inside Grasshopper. So if we go to the website here, you'll see that it's called Ladybug Tools. And if you scroll down, this is the mission and the legacy. And here it's telling us that there's basically 4 different ecosystems that are part of Ladybug tools. So Ladybug needs EPW files, which are standardized weather files. So these are examples of EPW files. So here's a website called ladybug.tools/EPW map, where you'll see that where global weather maps are available. So here, if I, let's say, zoom in on Tempe, where our site is, let's go to Tempe, you'll see that available weather files are, in this case, mainly distributed around the airport. So depending on the city density, we might have different sources that we could draw from. So basically EPW files, which are the files that we can extract. So in this case, for instance, if I look at examples of these, so I can copy them or download them, these EPW files. These are standardized weather data files that contain hourly data for an entire year, things like temperature, solar radiance, wind speed, and then direction as well. So EPW stands for Energy Plus Weather, and these files are freely available for thousands of locations around the world. You can download Ladybug tools from Food for Rhino. So let's go to Food for Rhino here. And this is not currently available from our plugin manager inside Grasshopper. So the way that we would be downloading this, and it's available both for Windows and Mac. Let's look at the latest version. So this is 2026-03-12. Go ahead and download this. And this is a zip file that we're going to be then looking at. The zip file not only contains the installation definition, so it's basically a Grasshopper file that would allow us to open and install, but also it contains example files. And these example files become really important. Right now, we're learning Grasshopper and we're constructing everything from scratch. But over time, you'll be able to basically develop a library that maybe you're using combination of example files. So for instance, here you could see that on Ladybug Tools, there's the example files, but also, for instance, let's go to, in this case, where we are downloading Ladybug. I'm going to just move that to my desktop. So I'm going to extract this, and let's see what's part of this. So when you open this ladybug folder, it has samples. And inside samples, you'll see that it's distributing it based on different properties. So for instance, Ladybug is the starting add-on, and Honeybee allows you to do more advanced calculation. Dragonfly and Fairy Fly, they allow you to do even more advanced simulation, but using urban scale. One really great resource, as mentioned, is basically the example files. So these are really detailed, annotated example files, but also we can quickly go back to the website. And if I go to, in this case, actually, I can also go here to if I click on each of these, for instance, Ladybug, then here I can get a general sense of what is possible. So for instance, if I go to Honeybee, it gives me the main features, and I think it's very, very friendly. One thing to keep in mind, there's many different versions of these Ladybug and Honeybee available, and sometimes these examples are not up to date. I always recommend just use the latest version from the website. In this case, it would be the folder that we just extracted. So okay, so let's make sure that first we save our existing Rhino Grasshopper files, because now we need to go ahead and install Ladybug. And to do that, if I go back to the folder, I'm going to come out of samples. There's this thing called an installer, and you always want to also read the text file, and the text file tells us that we want to open the installer file, and that's basically how we're going to install it. So I can either drag this installer file, so this is a Grasshopper file on our Grasshopper canvas, or I can go ahead here and then do file and open. Or even if I have Rhino Grasshopper closed, this latest version of Grasshopper, you can just click on the component, or sorry, the definition, and it will open the file as well. Regardless, make sure that you have this installer file open. And this is one of those processes that, depending on your operating system and what other dependencies you have, it might be a fast process or it might take some time. So basically our Ladybug installer file is just these two windows. And all we have to do is to just follow these steps. And step 2 might take a while. So keep in mind that I already have mine installed. So I'm going to go ahead and double click on the first one. So this should be quite quick. And it tells you that it also installed this thing called Open Studio and Radiance. Now the second one might take a few seconds. So don't overclick or don't close it. So you just double click and just wait. So it might take a few seconds. And give it time to process. And on installation, it will be also a similar thing. There's a definition there that you could open and then go through the installation process. So right now it tells me that Ladybug tools have been successfully installed. Restart Rhino to load the new component. So let's go ahead and do that. So you want to just give it some space for this thing to load. And if you're getting any errors here, just repeat the steps. And if you're not able to troubleshoot, you can use definitely platforms like ChatGPT or Claude, or please go ahead and email me and I'll be happy to meet with you to troubleshoot. It might be that you have an older version, but for the most part, you should be able to do this successfully. All right, let's go ahead and close this. So once you open your Rhino and Grasshopper again, you should see Ladybug as an additional tool, as well as Honeybee Radiance and Honeybee. So we're mainly going to focus on Ladybug, and the first series of menus on the left side, they allow us to import and basically situate our site. Then we have our analysis tool, visualization tool, geometric analysis tool, and then extra. So these components are quite extensive. And because they do rely on some of them specific settings, it's very, I would say, overwhelming in the beginning to begin to start and build this from scratch. And certainly plugins that are already coming with sophisticated example files, there's no need for you to start from scratch. And that's quite common when you begin to work with plugins. So if I right now go to my installation folder that we created earlier, or we installed earlier under samples, under Ladybug, there's an array of different examples that I can look at. We want to start from the very basic, which is a direct sun study. So I can either open from here, but better yet, because I do want to keep this Rhino file as part of the experiment. So go to your Grasshopper, go to File, Open Document, and go ahead and find that Ladybug folder under Samples, under Ladybug. And let's go ahead and open Direct Sun Study. And when you open this, it will come in with a predetermined geometry that we can simulate. So I'm going to walk you through this step by step. So first we import an EPW file. So this is a file that we can either download and reference or copy the address from here. Then that information is being referenced and then that statistic is being passed on. So this component, which we're going to use Control Alt and left click to see where it comes from. So this component allows you to further locate your file. Then we're creating a sun path and we're able to utilize our Ladybug sun path component here. So by default, it has a 20-degree offsite, basically orientation. So it's not necessary if your site is created due north. And then we could further detail anything from the center of your positioning all the way up to scale of the sun dome. So this is basically our sun dome. It has north, south, east, west. If I go to my top view, you'll see that basically this is 20-degree. It's going counterclockwise. Then we have a component here which allows us to set up the time of the study. So here we're looking at June 21st. And then if you hover over the timestamp, you'll see that it's suggesting a specific times to enter. So for instance, if I press enter 9, that time is not going to be calculated. And then that information is fitting into this thing called Sun Direct Sun Study. And if I were to preview this for you, if I, now that I have file list connected, if I go ahead and double click for this to become true, you'll see that now there's a projection of direct sun hours. So if this is our geometry, let's say a geometry that's casting shadow. So here the context is what it is that is going to cast or impact the floor. And then we have our geometry, that's the surface that we're studying, right? So in this case, that's reference here. So in our case, our context is going to be the building that's going to cast a shadow as well as the pavilion itself. And then the geometry that we're going to study, this will be the courtyard surface. Here we can play with the grid size. So for instance, instead of 2, if I want it to be finer, I can go down to 1. And this is the mesh subdivision, so Control M if you don't want to see that. And then I can certainly turn off the preview of the mesh here. And then at any point, we could also change the positioning of our legend. So that is a point that we already had in our Rhino file, and we can replace, etc., etc. So I want to just not modify this any further. I'm going to just turn this back to false. I'm going to just copy all of this, and we're going to copy this example file called direct sun study into our working Rhino file, and we're going to modify it for a specific site in Tempe. So go ahead and Control C, then open your file, the kangaroo file that we're working on, and I'm going to do Control V. Let's see. And I'm going to group it to itself just to make sure that, I'm able to isolate them when I need to. And I'm going to just label this that this is going to be my ladybug direct sun study. All right, so now that I'm in this folder, you can see that it has this pre-made geometry, all of those things. And we're going to fix this by doing a couple different things. First thing is right now, the default location is set up to be in Madison, Wisconsin. So let's go ahead and go back to our ladybug.tools/EPW map. And I search for Tempe here. And the most accurate weather stations are always near the airport, because airports need to have very clear navigation. So either one of these would work that for nearest. I'm actually going to go with one of these. So select and then press copy. So we can either download and reference the file, but I prefer copy because this way, if you move your file, the path is still valid. So just go here, double click, delete, then paste the new path. In this case, sun will be replaced with Phoenix Sun. Then all of this is fine. I will just adjust this back to 0. I can either delete this or adjust this back to 0, so then my north is facing up. So this is something you could play with. Then here, the center point right now, this is set to be 0, 0, 0. I think that's fine. Scaling, this is something we can create. Make a slider that goes from, let's say, 0.5, less than 1, less than 5. And ultimately, here we're just scaling how large or small the dome is. And it kind of depends on how you want to create your diagram. I'm going to keep this at 1 for now. Just know that you could change that. And then I'm going to add this to the group. I think everything else is fine. So then these are the vectors that are then allowing me to then visualize this sun study. Okay, so the most critical thing we need to do is to replace these two geometry, these two placeholder with our own geometry. So I'm going to rename this before we do that. So they already have kind of embedded geometry. I can empty this or I can keep them as is and replace them. It's up to you. What I want to do is I want to first rename them. I'm going to group it to itself. And this one, the context, that's basically going to be ground surface that we are analyzing. And then this one, this is the geometry. This is what it is that we want to sorry, this is so the context is everything that's going to cast a shadow. So instead of this could be my pavilion, this could be the surrounding buildings. So I'm going to say this is context casting shadows. And then the geometry is Control G. Just slightly, the geometry is surface BR static. So in this case, I can also just say this would be my ground surface. All right, so in this case, let's go back to our layers and make this a little bit easier for us to see. So I can either right click and then go down here and do something called clear values. And when you clear values, you basically empty the container. Same thing with this. And that will just make it a little bit cleaner. So just know that that's optional. You can either clear values or just directly connect to this, which is going to replace. To make this, I think, cleaner, I'm going to clear values. So now this becomes an empty container. So I'm asking, what is the ground surface that we're studying? So if you recall, we have this ground surface that I want to kind of see how the shadows are being casted. So I need to reference this. So here in your Rhino, it's called Geometry Courtyard. And I'm going to go here where it says Geometry, Ground Surface. I'm actually going to rename it called Geometry Courtyard. And it will be easier to find it later on. So we're studying, okay? So just go ahead and right click, do set one geometry and just select this. So now that is referenced already. Then it's asking for context. What is it that's going to cast shadow? So in this case, there's two things. One is the building. So in this case, that's the 3D building. And then one is the pavilion itself. I'm going to do this in steps. First, let's just reference that building. So I'm going to right click. Sorry, I need to make sure that this is not locked. I'm going to right click, set one geometry and just select this. And now that's what is, let's say, casting the shadows, except for this. But I want to try this. Just make sure that you go here and just double click and you'll see that there it is. So basically, without the pavilion, this is how it's studying the sun. And I can also hide this view so you can understand it better. Basically, you'll see that along the edges, you have less. And what happened to the legend? Well, by default, it is actually placing the legend here, but we're going to replace that shortly. So we can see that it's roughly working, but it looks like what I need to do is I need to also incorporate this with basically the context that's casting shadow. So how do I do that? Well, everything that we are producing, the final mesh, is coming out of here. And if I want to even look at upstream here, I can also get it from here. But let's just say we're doing this. To come all the way before we visualize your mesh, grab a mesh container or a geometry container. So then this way it could be any geometry. I'm going to grab a geometry container and then connect the output. And I'm going to bring that, and I'm going to first say we're going to pass the pavilion geometry to Ladybug. That's just for us to just basically migrate the geometry. And I'm going to bring it here. So I have the pavilion, and then I have the 3D building, right? So I can either merge these together or just create a third one. So I recommend creating a third one. So I'm going to say, so this is going to be, instead of context casting shadows, I'll keep that there. I'll make another one. Actually, yeah, I'll just keep this as the input. I'm going to just rename this, keep the name. I'm going to say this is 3D building. That's the 3D building that's already referenced. And this is the pavilion. I'm going to just merge it together. I can either use merge or another geometry container. So I say this and then hold shift plus that. Going to say this is everything that's casting shadow. And then I'm going to just group these together. And I'm sorry because it's going to start to, you know how it is, it's going to start to get messy before we clean it up. So I want these three to be in one group. Basically this, this, and this. Control G. And sometimes when you group within groups, you might see something like this where, you know, the text is being overlapped. Just select and do Control B. And that's basically the front and back. You can send things front and back using this. So Control B. All right, so basically the output of this context casting shadow goes into context, right? So just basically you have your pavilion, you have your 3D building, and then you're passing it on. And then here by default, it is also, it's already flattening, and you could see that, yes, it is actually, it knows that where you have the pavilion, there's going to be less sun. And then depending on the openings and whether, let's say, what if so see like here, we're not passing that on. I'm going to turn that off. So you see that that's basically the sun, but you don't need to do this, just pay attention. But what if I don't do the window? So if I go directly from here to here, you'll see that, yes, definitely without the pores, there's way less sun that's receiving here. But then if I go here with the suns, then you're getting, of course, more sun, right? So you can see that immediately we're able to simulate this, which is really, really great. And so this is working. I'm able to basically just simulate this. So let's organize this a little bit, and then we're going to go back and modify some of the variables. At any point, if you also receive red warnings here, you can just reset this. So similar to Kangaroo right now, Kangaroo is running and so is this. You could reset this. Okay, so next thing, let's go ahead and solve this legend issue. So if I go to my ladybug here, under here extra, there's components for modifying the legend. So LB legend parameters. So let's grab that. And this is a quite large component. But what it does, it actually allows you to create a new base plane. So we said base plane or a base frame. It could be a point. So let's grab a point container. So under geometry, grab a point container. And I'm going to connect this point first to the base plane. And then we're going to connect this legend. Here it says legend parameter. So again, sorry for making this messy, but that's one of the parameters. And then I just need to reference this point. So earlier we had this, let's see what layer it's on. Here, it's under legend. So we have this point here that you could utilize. I'm going to unlock it. All you have to do is right click, do set one point. There's that. And then here's your legend, right? So for instance, if you want to make a screen capture, this is a really, really great way to do that. I think it's exciting how quickly you could visualize this. And then of course you could turn certain previews off. You can apply custom color to any of this. So possibility of what you could do is endless. And then again, you can modify the geometry in order for you to have a variation. So let's look at some of the parameters here. So if I come here and look at the analysis period, so right now we're looking at month of 6, so June. So if I want to do, for instance, a December analysis, I would just move that to that. And of course, with December, we're going to have some areas that are not going to receive as much sun. Now that's very early, right? So let's select, for instance, 10 or 12. So here, if I go to, let's go to noon. And I will move this back to 6. Feel free to adjust the dates as you see fit, and all of that will determine what we're looking at. Okay, so last step, we're going to just apply color to this, and we're going to just bake it out with color. So then this way, if you want to take it into another software and continue the visualization, you can do this. So basically, the environmental analysis is, it also has some other variables. So here we saw that, for instance, instead of one value, if I do, let's say 8.5, or all of this could be even finer. And then there is an output here called mesh. And if I grab, let's say, a mesh component here, or if I just right click here, mesh, I can bake. And I'm going to place this under catenary pavilion. And if I just look at the output here, I'm going to go to my rendered view. You'll see that actually it is, right now I have two previews, right? So that's the original, but it gives me the mesh with color. So when we're working with meshes, we can easily embed the color. So you can take this into another software like Lumion or Twinmotion, and you'll be able to actually preserve this color. So this could be a great way for you to analyze your geometry, right? Now, if I go back again, and let's see, what if I want to embed color in my pavilion as well? So if I were to, let's say this is my, this is basically my custom preview here that I have. Of course, I can change the color here. But if I were to say, I'm gonna just make this more blue, something like that. If I were to bake this, and I'm gonna add this also to my catenary pavilion layer. So I changed the color here and I baked it. But if I come back to Rhino and without the grasshopper preview, actually the material is going to be material of my layer. So it doesn't by default embed color unless I tell it to. So this mesh already has the color embedded, but custom preview doesn't allow you to embed color. So we're going to do a couple of things. First thing, I'm going to make a new layer, and I'm going to have one that says Ladybug Solid Study Ground Surface. And that's what we're going to use to then migrate this to. So then you have that as a separate thing. You move it out. There we go. And then we have this layer called catenary pavilion. So now if I go to my, let's say, rendered view, and I could, see this. So in this case, I want to show you how to embed color from Grasshopper and bring it here. So I'm going to delete this. We're going to go back and call Rhino Grasshopper as well. So the other day we installed a plugin called Human, and that was for our GIS example in order for us to basically show color with thickness. So Human has a number of components for us to also be able to do other types of visualization. So in previous example with GIS, we looked at line thickness. But what you could do here also, you could bake your geometry with color and create attributes. So let's try to look at that. We're going to use this component under creation called bake geometry. So it looks like this, but actually what it's allowing you to do is to bake with color. So what is it that I want to bake? So the geometry is going to be the same geometry coming out of here. Then what is the attributes? So attributes are, it could be color, material, and other things. So under creation, we're going to use a component called create attributes. And you'll see that with create attributes, there's different properties I can incorporate, such as material, such as layer name. So let's connect this here. We're not going to work with this yet, otherwise it's going to start to bake. Then it says I need to create a material and a layer name. So let's go back here under here under documentation. Let's use this component called create or modify materials. And in this case, it will allow me to take any of these properties, such as diffuse color, specular, emission, and then provide it as a material name. So let's try that. So the diffuse color is the default or the base color. I'm going to actually copy this. And remember that this is for preview, but this one allows us to bake the color and take it out. So I'm going to select this and let's say provide this as the diffuse color. Specular is the color of your object when you shine light on it. So usually by default, this is set to white, but I could modify that. And let's say I'm going to go with like a lighter with a little bit of tint. Emission is the color of the shadow. So by default, this is set to black, but changing this could have a drastic impact. So let's say I want my pavilion to have a pinkish or a reddish tint. So that would be color of the shadow. Actually, it might be extreme. Maybe let's just do yellowish. So there's that. And I'm going to go a little bit darker. That's going to look like. And then alpha channel will be the transparency. And this could be a value from 0 to 1. So this might not look good, but I want to just give you a sense of what's possible. Then glossiness is a value between 0 and 1 again. So I can just keep building this up. I have no idea if this is going to look good. And at the end, I can also give it a name. And in this case, I'm going to call this my pavilion material. And there it is. And I'm going to group this together, Control G, and that's going to be my pavilion material. We can reutilize this. So there is no kind of science to this. I'm just demonstrating, so just try to follow along and just make variation. Then the other thing is I can also create a layer name here, so I can bake it and send it to a layer. So if I go back to human here, I could here create or modify a layer. So for instance, I can connect that to layer name, and I could say, well, create a layer name and let's call it, what should we call it? I already have, I believe, a catenary pavilion that has that a layer on. I could say my pavilion baked color, right? So it could be, or let's say baked material. And I just want to show this as a placeholder, right? So that becomes the layer name. I can give it a layer color. So for instance, make the layer color, grabbing, for instance, red. And there's other things as well, but let's just give this a try. So all of this, I am setting it up in a way that I can basically send geometry out of Grasshopper. And then last thing is I need to just set up a toggle here. And I'm going to go to my parameters under input, grab a toggle, a Boolean toggle. And if I set this to be true, so pay attention to my layers. And we're gonna see if we could do this. Let me change my view. So just keep in mind that right now, basically, I'm just looking at a grasshopper preview. And as soon as I set this to do true, you see that now I have my big pavilion material as well as this. So now if I go to my rendered view, which is here, you'll see that that color basically is more than, so it has this kind of weird tint, right? So you can certainly, delete, and that's the preview as is. You can also delete this. And then if I change my mind, I can do it again. You just need to know that when it's set up in a way that it's going to bake anytime that's triggered, if you don't want to continue, keep baking it, turn that off. And here again, I could say maybe call it my or ASU Pavilion material or something, right? So you can just keep creating new layers here. And then let's say I want emission color to be, very strong green for some reason, and then just go ahead and do that. And there it is, right? So ASU Pavilion material, and there it is. So along with that, I going to turn this off and then go ahead and just group everything together. Control G. I'm going to change the color of this group because everything here is basically just bake with attributes. And